Hey folks, welcome out there to TNLearn Mathline. I'm your host for this afternoon's session. I'm Ernie Roberts, and we are so glad to have you tuned in with us this afternoon. Hey, it's on one of those, specialized segments days. Yeah, that means we don't have call-ins today. Those you've been calling in this week, thank you. But today is one of those days where you get to sit back, relax. We'll do some math together, get you some pencil, get you some paper, all sorts of great things to go. You might want to bring a ruler just in case you want to do some drawings here today, all right? So let's see what the show's about this afternoon, my friends, and we'll get rolling here. Square. Oh, we're talking about the quadrilateral. Actually, the parallelogram, the well-behaved parallelogram, that is. So this is when I think of squaring, we're just going to say multiply two numbers together, square the number, take it times itself, all right? But this is not it may be a multiplication, actually. We're going to talk about the square. So let's get to business. Let's find out what's going on here as I ramble along. Don't y'all ramble with me, all right? Let's see where we're going. I think we're going to talk about what is a square first of all. Many times in geometry, we've already got our minds made up with this, that, the other. We know what a square looks like, but a lot of times we don't really think about what is it actually, all right? And those of you hopefully have been tuned in with us during summer school. This is getting away from summer school today, all right? We're back to, I know school's back in session, isn't it? Even though it's still summer, school's back in session. But what we got here, though, let's talk about a square. Everybody knows what it looks like. There it is. They're both squares. Why are they squares? Well, first of all, we got two options. It could be look at this, a rhombus with four right angles. And some of you are going like, a rhombus, what's a rhombus? What's a rhombus? You've been watching the show, you know. If you haven't been, we'll tell you, all right? It's got four congruent sides, all right? It's a quadrilateral with all four sides congruent to themselves, all right? They're all the same length. So on the other side here, we've got a rectangle with four congruent sides. So I tend to look at this, by definitions here, is a rhombus with four right angles. That means we start with the rhombus. So let's start over here. Let's say we're going to go for a rhombus, and then we're going to add some right angles, all right? Follow me on that. So first of all, that tells us, you and me, we have all those sides marked congruent. They look good, don't they? Yeah, all the same size. And you say, well, I thought all squares had. They do. All squares do have all congruent sides. But there's one other catch. You've got to have right angles matching up, all right? So that's the second basic procedure here, all right? So a rhombus means a quadrilateral or a parallelogram with all four sides congruent. Bingo. Then we're going to add right angles, and we get a square. It forces it to have to be a square. That's going to be our definition. Or, let's start with a rectangle. Now in the blue figure over here, let's start with a rectangle which has four right angles. Everybody watching me? Everybody following? Go. Now, what are we going to do? We're going to add the four congruent sides. And you say, well, Ernie, that pretty much looks like about the same picture. If they are the same size, I don't know if these sides are, but nonetheless, we are going to have the same conditions. So we can look at it as being a quadrilateral with all four right angles congruent, or all four right angles. They are going to be congruent, right? And all congruent sides. We could also call it a parallelogram with four right angles and four congruent sides. Or we could really get specific like we've done here. We've got a rhombus. Rhombus says four congruent sides, give us four right angles in addition. Or start with a rectangle with the four right angles and now tack on the four congruent sides. All in all, it's well behaved because, look, everything's perfect. All the sides are the same length. All the angles are right angles. Life is good when you're a square. And if you look on the bathroom floor and the kitchen floor, I bet somewhere in your house or a friend's house, there are square tiles, all right? I bet there are places you go, school maybe, where there are square tiles in the ceiling. They will do great things, all right? They're easy to pave with. They're easy to tile or to make a tessellation type on the floor. So it's a great parallelogram, but it's also a rhombus. It's also a rectangle. It's a little bit of everything, all right? So that's what we're going to look at. We're going to explore the square today. We're going to have a little bit of fun with it there. So if you're out there drawing pictures of it, remember, that's why I said you might want to have a ruler or a straight edge of some sort out there, creating some right angles and some congruent sides. Now, I mentioned a lot of things. First of all, I mentioned that we have a rhombus. I mentioned we have a rectangle, and if you'll remember, rhombus and rectangle are all part of the big mama parallelogram family. So let's go back and review the very parallelogram properties. All right, let's take a look at those, the basic ones here. First of all, if it's a square, it's a parallelogram. Now, if it's a parallelogram, is it always a square? No, no. You've got to have specific qualities to be a square. So let's go back and think about our parallelogram properties, just the basic ones. First of all, will we have parallel sides? Well, certainly we will. These sides are going to run parallel. They did in the rectangle, they did in the rhombus. They're certainly going to hold true in the square. So here we go. Mark those little figure points. Here we go, marking them. That's what we mean by showing them on the square. Also, we know opposite sides are congruent, well, because it's a square, right? All sides are congruent, so we go one step further. But yet, both pairs of opposite sides are congruent. It's good news. Are all opposite angles congruent? Well, they're right angles, correct? They're both 90 degrees. It means they're congruent. Also, how about it? Right, here we go. Here we go, another right angle. So we could put all those with nice little tick marks. They work also. Check it out. Are consecutive angles supplementary? In other words, do these angles, I'll put some letters on here for those of you who like those. I do too. A, B, C, D. Looking at A and B, do they add up to 180? Are they supplementary? Yes, yes they are. How about A and D? While we're at it, my goodness, yes, they certainly are. They add up to 180. They're both 90 degrees, correct? So 90 plus 90, 180. They are supplementary. Play the game, D and C. You got the idea. Same thing for B and C. So consecutive, all those great things are going on. Consecutive angles are supplementary. Wow, what can I say more? How about it? Let's test out our diagonals. Let's take a look at those. Now, you know, the idea is they're supposed to, ooh, wow, pretty colors there. Yellow kind of disappears. Let's draw a diagonal right through there and take it right through here. We're just talking about parallelograms right now, my friends. Just about parallelograms. There are other special things because it's a rectangle and a rhombus. But we do know this much. They are going to bisect each other. So I'm going to put double ticks here. And I'm going to put double ticks there. And you say, Ernie, how did you know that? Well, first of all, I know these two go together. If I were to meet here at X, I know these two go together. I know these two go together. Now, I went and kind of cheated a little bit. You say, maybe I did. How do we know all four of these get the same tick marks? That's a good question. And you know I did mark them. Maybe I went a little ahead of schedule there. The diagonals of a rectangle, remember we got a rectangle going on here, they are what? They are congruent. So if you have the same length from B to D, up here, as you do from A to C, and you cut them in half, guess what? Half of the same amount is going to be also. It's got a little multiplication or division property of equality going on there. So that's going to tell me all four of these little segments, the AX and XC, yes, they work. BX is certainly congruent to XD, but now we can connect all four of those together. And that, folks, is going to be some important information for us as we start exploring what is really going on that makes a square so specialized, even more so than being a rhombus or, goodness, a rectangle, all right? So anyway, the properties, those 6 big properties, oh, by the way, if we were to divide one diagonal through there, I forgot to tell you, yes, these would both be congruent triangles very easily because you would have two sides matching up to two sides here, the right angles. My goodness, you got reflexive. You've got side, 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 or side angle side. So yes, one diagonal at a time makes 2 congruent triangles. Whew. But what about, oh my goodness, there's a whole story in there. What about happens when the 2 diagonals come together? We're going to look at that here in just a second. So now you see it's a parallelogram. It has to be, by definition, being a rhombus or being a rectangle, and actually a combination of both. The properties of the parallelograms must hold. They've got to hold. So let's go and explore a little bit more on this thing, all right? I remember we have, when the 2 diagonals pop in, you got 8 triangles happening in the figure, all right? 8 triangles. So let's see how that works with the properties of the rhombus and the rectangle here. So let's take a look at a couple of pictures here. Now, I decided to change the, I didn't change the shape. It's still a rhombus, okay? But a lot of times we look at a rhombus more in a diamond shape, a diamond look. That's just kind of the way we do things, just like when we look at a kite in a certain way. We don't usually look at it long ways. We look at it in a vertical fashion. But then we've also got it back to our rectangle, which we tend to think, okay, we got all our nice little right angles here, right? So what we want to do is show the properties for both the rhombus and the rectangle on the squares here. Now I'm going to go ahead and say we have a square here, which means, hang in there with me, we're already going to tell you that we have those marked and we also have the right angles. Now I'm going to play rhombus on us here, all right? I want to play rhombus on us here. Now, if you remember, when we drew the diagonals in, because rhombus, right by the way, everything's good, right? We got 4 congruent sides. It's a parallelogram. We know that. So all I've got to do is worry about what happens with the good old diagonals. Well, remember, we draw one in. We draw one in here. And look, we've got isosceles triangles, don't we? Not only that, we have right isosceles triangles because we have right angles up there in those 2 corners, all right? Now remember something else. When we have a rhombus rolling through here, remember it splits the right angle in 2. Remember, it divides, the diagonal divides those opposite angles. So we are going to get a little tick mark here going. Whew, we're going to also get, we're going to get the same tick mark because we're dividing 90 degrees. So what are we going to do? We divide 90 in 2. We're going to have 45 and 45. So these guys all get tick marks also. So things are starting to happen here. Isosceles. We got 45s here. Got 45 degrees here. And we got 45 degrees here. Very interesting. And what happens if I draw another diagonal in? Wow, gets intense, doesn't it? So here we go with our rhombus. There we go, connecting it. What do we know about the diagonals of a rhombus, my folks? Yes, they do. They bisect each other, and they also are perpendicular. Now here's where things get very interesting also once again. If these are 90 degrees here, we're going to be 45. That forces another 45 here. Well, it's also bisecting the diagonals, right? So if I start with a rhombus, all sorts of things are happening. All things are happening here. My goodness, there's 45 degrees everywhere. You say, well, Ernie, if you start with a rectangle. Nope, if we start with a square, can you go back to the properties of the rectangle? I've left out one little property. We're going to come back to it in just a second on this picture, all right? We do know these diagonals are bisecting each other, all right? And we got one important thing that since we add the rectangle in there, what will happen with the diagonals of a rectangle? Well, first let's put those right angles in there. You all love them. I do too. So we've got our right angles for the square. We've also got our little tick marks. I'll put another one here. 2 ticks on this, just in case. These might not be matching pictures exactly congruent. Let's draw those diagonals in and see what happens. Now remember, what property, we mentioned it just a little bit earlier in the show. Flip that over. And let's do there. I brought a little Curious George in to play with us there. We love Curious George here on East Tennessee PBS, as well as Upper Cumberland PTS too, all right? We love that little guy there. And again, remember now, these diagonals are congruent, and they're bisecting each other. So we know, without a doubt, that these are all going to be bisecting each other congruently there. So things get interesting. Guess what? We've got all these 45, 45, 90s once again because, well, congruent diagonals. And we're going to find out, did we get bisected there? Well, if it's a square, we certainly do because the rhombus holds, correct? So again, here we go. We're going to have 45 degrees here, 45 degrees here, 45, 45, might as well. Got a rhombus happening. That's the new baby. But look, with all these 45s, it has to be 90. Has to come out to be 90, right? Got to be 90. And here comes 45 again. Do you get the idea? How they work together. And by the way, now we know these little guys are all 4 of these little parts of the diagonals are also congruent on our other figure. So whether it looks in that diamond look like a rhombus there, or here it looks like what we think of as a rectangle. But once we bring in all four sides congruent and all four angles to be right angles, dear friends, we have the square with some amazing, amazing properties, all right? And that's what I wanted to do with you here, is kind of exploring. Show the properties for both the rhombus. You see it? Angles being bisected here, also up here. There you go, at both diagonal ends. Forces, 45-degree happenings, all right, if you've got a square. Over here, once we started creating these diagonals, these forced the 45s to happen because it's an isosceles triangle. We've used up 50, we're going to have this 90, but once we pick up the 45 and 45 here, we get the 90 there because that's the squeezing effect of being a square. So either way, these properties hold. The properties for the rectangles, congruent diagonals, also bisecting opposite angles, you're always going to get those 45s and 45s, which creates these 45, 45, 90s. Enough lecturing on the square today, right? Well, we're going to play with it some. Let's play with it a little bit. And let's see what we've got coming up next. The question was, what kind of triangles will we have formed by the diagonals of a square? So let's take a look at it here. Let's take a look here. And let's start with the big ones. Just one. Just throw in one. And I will tell you what's going to happen here, and we're going to hopefully explore together. So first of all, we just draw in one diagonal. We have right angles popping up here. We definitely have all these lovely creatures congruent. So I'm seeing isosceles triangles. I'm also seeing a right. So it's an isosceles right triangle. Not one, but two. 1, 2, big ones, all right? They're congruent. That's what the diagonal of a parallelogram does. Diagonal of a rectangle, diagonal of a rhombus, they all form congruent, one of them at a time forms congruent triangles. Now, bring in the other one. Bring in the other diagonal. And you know what's going to happen? Of course you know what's going to happen. You just saw it happen a minute ago, but we're going to play it out again, real quick fashion. We now have two more big isosceles right triangles. Wow, all right? So at this point, I have, if you look at these two, glue them together, one big triangle, one big triangle, one big triangle, and one big triangle. So I'm counting up 4 big isosceles right triangles right now. Let's go inside. We got little smaller ones anyway. Let's see. I'll call them little triangles. My goodness. Guess what? They're right triangles because it's in a rhombus, so the diagonals are perpendicular. And, you know what? Diagonals are going to be congruent. They're bisecting each other. It looks like I've got some more isosceles right triangles. All of these are, I've got 8 of them, 8 isosceles right triangles. And you know what that means? Everybody knows what that means? What kind of degree measures do we have? Let me elaborate a little bit. That means we're going to have 45, 45, 90-degree triangles. One of our special right triangles. Great, great things there, all right? So it's very, very critical that we see those triangles popping up. And like I said, there's 4 little ones, and there's 4 bigger ones, all right? And those are your all isosceles right triangles because here's a 45, here's 45, here's 45, here's 45, here's 45. See the big triangle? 45, 45, and the big 90. 45, 45 down here, and we got the big 90 there. We can split that up. You get the idea. Wow, all of them, 45, 45, 90s. So there you go. You've got some nice picture of some of our triangles that are going on within the show there, and that's what makes that such a well-behaved quadrilateral. Now, we've already been looking for the angle measures in a square, right? So we know they're either 90 degrees or 45 degrees, and that's about all we can do with them, all right? You say, what do you mean, Ernie? How do you mean that's all we can do with them? Well, you split 90 degrees, you can only get 45, all right? You split 90 degrees, you only get 45. You get the idea. You're going to see either 90 degrees or 45 degrees, and all of when your diagonals come to play. And without the diagonals, you're going to see all 90 degrees. So there you go. How about it? Let's take a look at some examples. Let's do some arithmetic. Some of you are saying, when are we going to do some math? We've been doing math, but you got to understand what's going on first. 45 degrees, hey, and 9 degrees. You got that down. Let's do, it says AB. Now you said, what's our AB? AB, we're going to let it be a side. Okay, so we'll put A, B, C, D right along the edge there. So we're going to put a 10 right there. Now, it's a square. So guess what? We got right angles. We know we've got congruent parts. So that means all these sides are worth 10. So if you know one side, you got the perimeter real easy. Just multiply by 4, right? Got 40. But in this case, we're looking with 10, but we want to find each diagonal. Now, I'm going to tell you something. If you get one diagonal, you've got them both. So let's just play for one diagonal. That's all we need. And got it going right here. Draw it. If we can get it to draw here. Come on, Curious George. Get me where I'm going. Thank you. There we are. Now, I want to know what's the length of the diagonal. We'll call it D here. And I hope everybody out there who's watching today notice you've got a right triangle going there. And I know 10 and 10. How do I know 10 and 10? Because it's isosceles. And because I know it's a square. All right? Because these two sides are the same measurement, same length. Now, let's play it. Pythagorean theorem time. Let's go over here and see what we've got. Got 10. Remember a squared plus b squared? Let's go for it. 10 squared plus 10 squared equals, we'll call it d squared here. Now that's our little d, all right, which is the c of the hypotenuse. Pythagorean theorem rocking and rolling for us here. Adding up, well, I hope everybody knows 10 squared is 100. I do. And 10 squared again, it's going to give you another 100. You have d squared rocking and rolling for you there. Let's do what we need to do. Add first. We're going to get 200. And that is our d squared. Now, we want to know about d. We're not really interested in d squared because we want to know what's the length there. What's our guy there? So let's take and square root both sides because that's how we get back to d. So we've got this d left over here, but over here we are going to have to do a little bit of work because 200 is not a perfect square. So many times on Mathline, I give you numbers with perfect squares. That's kind of maybe cheating you a little bit. So today we don't have a perfect square. But let's see what we're going to do. First of all, we're going to put it in radical form. And then we'll go to the calculator and see what it has to offer us, all right? What that radical form means in decimal approximation, all right? So let's see. We've got the root. We've got a 100 times a 2. Now, why do I do that? Because I have to break this down to a perfect square times a number. When you say 200, you're just going like, man, 100 is saying, use me, use me, use me. It's right there just crying for you to do that. So we've got 100 times 2. 100 is a perfect square. What is the square root of 100? It's going to give us 10. What's the root of 2? I don't know. There we are. We'll just call it 10 times the root of 2. That's what we call simplified radical form. Okay, it's a simplified radical there. You can't break the root of 2 down, but you certainly could get the root of 200. Now, sometimes they want a decimal approximation. Most of the decimal approximation is just that. We're going to change the square root of 200 into a decimal, maybe to the nearest tenth, to the nearest hundredth, whatever the problem is asking you to do. So what do you do with that, Ernie? We're going to go to the calculator, all right? It's the best place to go in the world for a square root to be done. So let's take a look at it. Let's go to, and by the way, watch where we're going there. We're going to the second button, and we're going to go down to the x squared right there. I know for some of you probably going like, can't quite see it, but there's a square root symbol right there where my cursor is pointing. There it is. So we're going to hit that, and goodness sakes, it gave us that. It gave us a great little picture there. So let's put a 200 in there, and let's see what we get. We get 14 and a little chump change. It rambles on. It's irrational, my friends. It's irrational. Now, you say, well, that doesn't look like 10 roots of 2, or maybe it does. Well, let's find out. Let's put a 10 and go ahead and hit that square root button, that second square root. There we are. And put a 2 right in the blank there. And let's see if it gives us the same value. Why, it certainly does. So they're both equivalent expressions. One is simplified. One is quite valid. All right? Now, what will we do in this? Probably, you would ask, let's say, D will go with approximately 14, and we'll just round it out to the nearest hundredth. In this case, 14 hundredths is where we go. Notice I've got these little wavy, looks like I couldn't get together to make a good equal mark. That means approximately. Okay, it's an approximation there. That's close to it. And we rounded off to the nearest hundredth. Pretty close. If you want to get tighter, you can always specify to a different decimal place. So that's our story. That's our story today a little bit. Now, Tune in some next week. We're going to be back live, okay? But we'll also look at some of these problems and maybe do some more working out. Didn't get quite as far as I wanted to on putting some numbers in there, but you see the formula, Pythagorean, it's going to come back and take good care of you in a lot of respects. Also, those of you who've already had 45, 45, 90s and their special rules, we're going to talk about that in one of our specialized segments on down the road, as well as the 30, 60, 90. Triangles, the basis of all these quadrilaterals, and also the basis of so many of the things we're going to be learning on Mathline on these specialized segments this year as we delve into deeper and deeper into geometry. Yeah, I know everybody's wanting to hear about geometry, right? We're doing it this year. We're going to do it this year. It's going to be our focus. It's going to be our focus. Hey, thanks, folks, for tuning in this afternoon. Hope you've learned a little bit. Hope you got a little bit of squaring going on and know how well-behaved things can be. We're going to be back again live coming this next time, but you also be sure to tune back with us next week, and we'll see you then.